Okay, calculus, you've now seen this problem summarized a little bit. I'm going to investigate just a little bit more with you, make sure we're all on the same page. And we checked to find the area from 0 to 10 underneath this curve. And as we did, we started to construct our different rectangles. That was kind of the goal. And in order to do so, I'm just going to show two examples here. Number one, I'm going to create two rectangles. So that means that each one would have a width of 5. So my first rectangle would be here. And my second rectangle would be here. And we all agree that that's an overestimation. As you can see, this red region is overestimating the area of the rectangle. As we calculate the area, you can see that the width is 5, and we would multiply that by the height. So 5 is the base, and then I need the height. And here, how do we determine the height? Well, we use our function. So the height is 3 roots of 10. And here, the height is equal to 3 roots of 5. So we have 5 times 3 roots of 5 plus 5 times 3 roots of 10. As you notice here, you end up with 5 times the quantity, 3 roots of 5 plus 3 roots of 10. Or in other words, the width times the sum of the heights. The width times the sum of the heights. And so if we were to go a little bit further here, and instead of doing 5 rectangles, or 2 rectangles, let's switch that. Let's do 5 of them. And if we used 5, hopefully you can see that over an interval of 10, the width would be 2. So this would be my first one. Second one. Third one. Fourth one. And fifth one. And so the width for each of these is 2. And then the height is going to be whatever we get when we plug that value into the function. So 2 times 3 roots of, that's going to give us our height, 3 roots of 2. That's going to give us our height, 3 roots of 4. That's going to give us our height. That's going to give us our height. That's going to give us our height. That becomes very helpful. So we can compute that on our calculator. For this sake, I'm also going to factor out the 3. So 2 times 3 is 6, so 6 times the square root of 2 plus the square root of 4 plus the square root of 6 plus the square root of 8 plus the square root of 10. And as you do that, notice you come up with 71.12, which we said was a slight overestimation for what we're looking for. We're not surprised, as you can see, these green regions provide an overestimation. What I want you to understand as you move forward, that we will not, we will come to times where instead of drawing the rectangle to the right side, we'll draw it to the left side. So let me show you what I'm talking about. See if this goes away. Get some of this to go away. Well, there we go. So if I would look back at, say, this last rectangle over here, notice that I have a right side to the right side to the rectangle, and I have a left side to the rectangle. If you draw to the right side in this situation, it is a overestimate. Whereas now I'll use green. If you go to the left side and draw it up and over the other way, then it becomes an under. It's not always the case that right side is over or left side is under. Sometimes they switch. It depends on the shape that you're working with. But for this lesson, just for this lesson, you are always going to be looking at right side. The big problem that we come up with in calculus, first semester was this problem. It was, we have a curve and we'd like to know the slope of a line tangent at one point. That is, where you have a function f and the slope is equal to f prime. That is the fundamental idea of differential calculus. Well, now we're doing something called integral calculus. And this is the basic question that comes up in integral calculus. Suppose that this is a function, and suppose that we're going to bound that function by some value a and some value b, and the x-axis. The question is, what is the area that's formed in this region here? What's that area? That's the big question that we have. It's not difficult to talk about. It's not difficult to say what the problem is, but determining that exact area, and I don't mean an estimation, I mean exact. That's a really good question. And so it starts by building rectangles. It starts by building rectangles. And so let's just review what we talked about in the previous one. Let's use an easier example. Find the area bounded between the curve. F of x is x squared, so this is x squared. It's a parabola. The x-axis, which is down here, and the line x equals 4. We have 4 right there. So we want to find that exact area. And we're going to estimate it by making 2 rectangles, by making 4, and by making 8. And we're going to use this idea. We're going to take the width times the sum of the heights. If we make 2 rectangles, that means that we are going to have a rectangle at 4 and a rectangle at 2. So I'll use black in this situation. Rectangle at 4, a rectangle at 2. So that's my drawing. The width is 2 times the sum of the heights. How do I determine the height? I take 4 and I plug it into the function and I get 16. Then I plug 2 into the function, I get 4. So 2 times 20 is 40. So 40 is the estimation. We know it's obviously an overestimation. Let's see if we can make a better estimation. Now I have 4 rectangles I'm looking at. So that means that I'm going to have divisions at 1, 2, 3, and 4. Or the width is going to be 1 each time. I always go to the right side. So from 0 to 1, I go over to 1. From 1 to 2, I go over to 2. 2 to 3, I go over to 3. And 3 to 4, I go over to 4. So always making sure you're drawing it on the right side of the interval. Okay, well, that looks like a better estimation. The width is 1 times the sum of the heights. So to get the first one, I square 1. Then I square 2. Then I square 3. And then I square 4. 9 plus 16 is 25, plus 5 is 30, times 1 is 30. So 30 is a better estimate. We cut 10 off of it. Good work. You guys are smart. So what about 8? Let's do that one together. I'm going to bound it all the way over to 4. And we like to divide into 8. That means that's cutting it in half. That's cutting into fourths. 1 half, 3 halves, 5 halves, 7 halves. If you want to use decimals, you can. 3.5, 2.5, 1.5, 0.5. It's up to you. And now I'm going to go ahead and I'm going to draw the first rectangle. Second rectangle, third, fourth, fifth, sixth, seventh, eighth. You can see that this looks like a pretty good estimation. We're not over the curve by as much as what we were before. But we need to determine the width. The width is 0.5. And then we will look at the first height is determined at 1/2. So 1/2 squared plus 1 squared plus 3/2 squared plus 2 squared plus 5/2 squared plus 3 squared plus 7/2 squared plus 4 squared. So we have to add all those up. 0.5 is my width times the sum of the heights. 0.5 squared plus 1 squared plus 1.5 squared plus 2 squared plus 2.5 squared plus 3 squared plus 3.5 squared plus 4 squared. I get 25.5. So it looks like we're starting to narrow down on the value here, 40 to 30, and then 25.5. If we cut off 10 here and we cut off 4.5 there, my guess is that we would cut off even more, maybe about 2 on the next one, and maybe then say 1 on the next one. So maybe it'd be somewhere around, I don't know, like 22. 22 might be a good estimate for that actual area. So on your worksheet, as you kind of look at things, that's going to be the first thing that you are going to do. So as I take out this worksheet, you have a function. Notice the interval, and you're going to divide it up into 2 rectangles, 6 and 12. 2 rectangles, 4 rectangles, 8 rectangles. Here's your function again. Here's your interval, 2, 4, and 6. That's part of what we're going to talk about when you return to class. The other part is how to estimate using other pieces. So we are given a function, but what if we're not given a function? What if we are given a table? Okay, it says do the following table to determine the approximate area bounded beneath the function over the interval -2 to 6 by using 2, 4, and 8 rectangles. So we still have the same idea. We have the width times the sum of the heights. That's what we're trying to accomplish here. And to go from -2 all the way over to 6, that's a distance of 8. So if we make 2 rectangles, that means that the width is going to be 4. So I'm going to go over 4. So -2 to 2, that's going to be my first rectangle. And then 2 over to 6, that's my second rectangle. Okay. And so now we need the heights. Well, remember, you have the right side and the left side of this. You evaluate the height at the right side of it. At the right side of it. And what do we use to evaluate the height? We use f of x. And so the first height is 7, the second height is 6. And 4 times 7 plus 6 is going to give us 52. Suppose we move on to 4 rectangles. Over an interval of 8, that will give a width of 2. So therefore, I go from -2 to 0, 0 to 2, 2 to 4, 4 to 6. Width of 2. So the first height will be 1. Next height will be 7, then 8, then 6. 14 and 14 is 28. I'm sorry, 8 and 14 is 22 times 2 is 44. We've moved to 8 rectangles. That's not too bad at all, is it? 8 rectangles can be pretty straightforward, just width of 1 each time. And again, we're talking about the right-hand side of things. And so 1 times, we start by adding up, again, the right side. So we start with 10, and 1, and 5, and 7, and 16, and 8, and 5, and 6. Get my handy dandy calculator out for that. 10 plus 1 plus 5 plus 7 plus 16 plus 8 plus 5 plus 6. Probably could have done it without my calculator. 58. There you have it. So if you're given a table, that's how you approach that type of problem. And finally, what if you're given a picture? Well, there we just really try to estimate. So determine using not the table, but use the following graph to determine an approximate area bounded beneath the function over the interval 0 to 8 using 2, 4, and 8 rectangles. So we're only going over to 8. So we're stopping here. Okay, we're stopping there. So using 2 rectangles, we would go here and here. So again, the width is going to be 4, and the heights appear to be about 9 and about 4. 9 plus 4 is 13, times 4 is 52. So I would say approximate area of 52. What if we had 4 rectangles? Well, then that means that the width of each one would be 2. So that's my first rectangle. That's my second rectangle. Third rectangle. Fourth rectangle. So width of 2 times our first height, about 9. Next height, I don't know, maybe 8.5. We're estimating. The third height, about 7. And the next height, maybe about 4. 9 and 8.5 is 17.5. 17.5 plus 11 is 28.5. And 2 times 28.5 would be 57. So that's our estimation. You can see in this situation, we're underestimating everything. There's lots of area to the top. For our last one, 8 rectangles. Over an interval of 8, each one will have a width of 1. So we have a width of 1, width of 1, width of 1. You can see we had overestimation there. We're very close. Here we're just barely underestimated. There's more underestimation. But this seems to be giving a really nice picture. At the end here, obviously, we have a lot of area that we're losing out on, but we did our best. So 1 times the following. Maybe 8.5. The next one here, I'm going to say that's about 9. I'm going to say the next one's about 9. Let's say the next one's about 8.5. And the next one, I'm going to say that's about 8. And the next one, I'm going to say that's about 7. Next one, I'm going to say that's about 6. And the next one, I'm going to say that's about 4. Again, we're estimating. If you came up with a little bit different results, it's going to be okay. We add these up. I have 18 and 17. 18 and 17 make 35. Plus 10 is 45. Plus 15 is 60. So it looks like I've got 60 out of that. And there you have it. So that takes us to our next lesson. So again, on your worksheet, notice that you should be able to work through those problems that involve the function. And then if you're given a picture, just estimate. We did that together on our last example. Another picture, and then you have a table there and a couple tables here. So that should help you out. Good luck, folks. I'm sure you'll do great. We will talk to you soon in class, right on the dot for 20 minutes.